This is lesson 6.5, Inequalities in one triangle. So the triangle inequality theorem says a triangle only exists if the sum of the two smaller sides is greater than the third side. So this is different than the Pythagorean theorem because we're just talking about sides that make up any triangle, not just right triangles. So they're telling us the sum of the two smaller sides has to be greater than the third side on its own. So we're going to determine if any of the following side lengths could form a triangle, and we're going to prove our answer with an inequality. So the first thing I would do is I would make inequalities, or make the start of an inequality, where I take the two smaller of the sides, and they might not be in order. So this one it's 8 and 17, this one it's 12 and 25, this one's 28 and 22. I'm going to add those together and then compare it to the third side, which would be the largest. All right, so that's what I've started out doing here. So now we're going to actually do this. This is 25. Is 25, what is that to 24? It's greater than. So this is yes. This will form a triangle. So number 2, 3 per 3 is 6. 6 is not greater than 7. It's less than. So this is no. All right, here we have 25 plus 12 is 37. And 37 is in fact greater than 35. So that's yes. Sorry for my words here. 37 plus 42 is 79. 79 is way bigger than 52. So that's yes. All right, here 22 and 20 is 50. That's actually equal to it. Equal to it does not work. Has to be greater than. So this is no. All right, here 6 and 14 is 20. 20 is bigger than 18. So that's yes. All right, 11 and 12 is 23. 23 is actually less than 24, so that's no. And 7 plus 35 is 42. Even though it's only slightly, it is bigger than 41, so that's yes. If I want to be determining what the possible third side is, so given the two side lengths of the triangle, what is the range of possible side lengths for the third side? We're always going to set up an inequality where we take the difference of the two numbers less than x, right? The x is our third side, less than the sum of the two numbers. And that's going to be the formula that we use to come up with these inequalities. So for the first one, the difference of 22 and 14 is 8, and the sum of 22 and 14 is 36, which means our third side could be anything bigger than 8 but less than 36. So we do that for the next one, 31 and 28. The difference between 31 and 28 is 17. Nope, it's 3. Wow. I think I did 38 and 21. Let's get rid of that. 3. And the sum of 31 and 28 is 59. So our third side could be bigger than 3, but less than 59. And let me just fix it here again, because that's ridiculous. All right, for 3 and 11, if I subtract them, I get 8, and if I add them, I get 14. So my third side has to be between 8 and 14. So you're going to try this, same idea, given the two side lengths, what is the range of possible side lengths for the third side? Try it. Pause when you're ready to see your answer, hit play. All right, assuming I didn't make any crazy mistakes like last time, for part A, it's between 26 and 64. For part B, it's between 17 and 31. And for part C, it's between 9 and 25. In a similar vein, if we were given the two side lengths of the triangle, I want to check off all possible lengths for the third side. So if my numbers are 15 and 27, I would make my inequality, right? Subtract them as 12, add them as 42. So anything bigger than 12 but less than 42 will work. So 34 is between 12 and 42. That'll work. 12 is equal to 12, so that's out. 29 is between 12 and 42. That'll work. 18 is between 12 and 42. That'll work. But 43 is bigger than 42, so that's out. You're going to try this one. pause. When you're ready to see the answer, hit play. All right, so because our number has to be between 36 and 54, 35 is below that, 58 is above it, 54 is equal to it, so the only two that work are 39 and 47. Ordering angles and sides. So what we could do is we could put the order, the sides or angle measures in order from least to greatest on a triangle. I can put the angles in order by comparing the sides. So the smallest angle is always opposite the shortest side, and the largest angle is always opposite the longest side, which means the middle angle is always opposite the middle side. So if I wanted to order these angles from least to greatest, I'm going to start by listing their sides. So that's what I did here. 7 was the smallest number, and that was side BC. Then we had 10, which was side AB, and then I had 13, which is a side AC. So opposite each of these sides is the corresponding angle. And if I have the letters, I can actually just say the letter I didn't use. So opposite BC is A. And the letter I didn't use when I said BC was A. So that's angle A first. Then across from AB, the letter I didn't use is C. So that'd be angle C next. And then AC, I didn't use B, so then B is the biggest angle. And the same thing can happen to order the sides. I'm actually going to use the angles. So the smallest side is always opposite the smallest angle, and the largest side is always opposite the largest angle. Sometimes we'll know all three automatically, but other times they're only going to give us two because they assume we can find the third, because every triangle adds to 180. So if I did 42 plus 103 plus something equals 180, I actually get 35 from my last angle. So now what I would do is I'm going to look at the smallest angle in this picture was F, then my next angle was E, and my last one was D. So I start by putting the angles in order so that I could put the sides in order. So when I'm talking about angle F, the two letters I didn't use were E and D. So that means ED is the smallest side, right? The bar. We know after E, F and D were not used, so we'll use FD next. And then for D, I didn't use F and E, so that's my biggest side. All right, but it's always the one that was opposite it. So if this is where 35 was, that opens up to this side. So that's what we'll do in our first example here. We want to list the angles from least to greatest, and we know the three side measurements. So I'm going to list the letters of the sides in order, starting with the side that's 26, then 29, then 43. So that's XY, then WX, then WY. So if I look at what letter I didn't use out of W, X, and Y, here I didn't use W, here I didn't use Y, and here I didn't use X. And that's all I have to do to put my angles in order. All right, for this next one, we want to put our sides in order. So I first have to find my missing angle, and then I can put the three letters in order. So my missing angle is actually 92 degrees, meaning J is the smallest, L is next, and K is the biggest. So across from the J, what two letters we didn't use are L and K. When I'm looking at L, I didn't use J and K. And then when I used K, I didn't use J or L. So those would be my sides in order. I'm not so much a stickler about putting the bars. I'm okay either way. So you go ahead, try these four. We're going to list the angles in order from least to greatest for this one, the sides in order from least to greatest for this one. Choose which of these statements is false. So find your missing angle first and then figure out what is true, which three are true, which one is false. And then here, which is a possible side length. Select all that apply. Pause when you're ready to see the answers. Hit play. All right, so for check-in number 1, I listed my sides first with RS, ST, and RT. Then I had my angles, angle T, angle R, and angle S. For check-in 2, I found my missing angle was 46, listed my angles in order, and then I had my 3 sides according to what letters were not used each time. For check-in 3, I found my missing angle was 48 degrees, meaning these two angles were the same, so it was isosceles, so I immediately got rid of that. Then they said the sum of two sides is greater than the third, which is always going to be true if it was a triangle at all, so we could eliminate that. So then it was down to these two. Is UV bigger than TU, or is UV less than TV? So UV is across from the 84. That should be the biggest side of this triangle because it's across from the biggest angle, which means it has to be bigger than any other side. It cannot be less than any other side. So this is the one that's false. That is our answer. And in my last one, finding my last side, I know I'm comparing ST, and the only other side I have is SR. So I'm comparing ST to SR, which means I'm comparing the 56 and the 59. So 59 is greater than 56, which means ST is greater than RS or SR. And I know that that value is 8, so ST has to be bigger than 8. So the two answers that were bigger than 8 were 9 and 10. And that is the end of 6.5 inequalities in one triangle.